morning students. Today I am going to start with the second normal form. The second normal form was introduced to overcome the anomalies faced in the first normal form. In this presentation, I will be giving you a recap of the anomalies faced by the tables in the first normal form and then show you how to overcome those anomalies using the second normal form. The above table student device is in first normal form as the attributes or the columns in the table do not hold multiple values for a particular SID. This can be seen from the entries in each of the rows. From the first two rows, you can easily understand. For SID with value S10, the columns DID, DNAME, DCost, DProfit and QTY do not hold multiple values. It holds only a single value, which is D10 for DID, RAM for DNAME, 850 for DCost, 20 for DProfit and 1 for QTY. Again, for SID with value as S20, the columns from DID, DNAME up to QTY also do not hold multiple values. It holds only a single value, which is D20 for DID, pen drive for DNAME, 400 for DCost, 20 for DProfit and 2 for QTY. So clearly, the above table is free from multi-valued attributes and hence it is atomic and also in first normal form. Even if the table is in first normal form, it is not free from anomalies or problems. Tables in first normal form suffers from anomalies such as insert anomaly, delete anomaly or update anomaly, which I will explain in the next slide. Just consider the table student device in this slide. All the rows in the table are uniquely identified by the SID. This is because each entry under the SID column has distinct values, which are S10, S20, S30 and S40. Clearly, there are no duplicate rows. That's why SID acts as a primary key column for this table named student device. This table holds two pieces of information. One for the student represented by the columns SID, SNAME, SCT and SState, and the other for the device represented by the columns DID, DNAME, DCost, DProfit and QTY. QTY here means quantity. However, if you consider the columns DID, DNAME, DCost, DProfit and QTY, you will notice that there are duplicate entries for these columns as represented by the entries with color red. Each colored entries holds the values D10 for DID, RAM for DNAME, 850 for DCost, 20 for DProfit and 1 for QTY. In such cases, we may encounter three types of problem. Those are insert anomaly, delete anomaly and update anomaly. Let's understand how it occurs. The first type of anomaly is the insert anomaly. An insert anomaly arises due to failure to place information about a new entry in a table. In the next slide, I will show with the help of an example. Just consider the table in this slide. If a new student, say Pranav's data, needs to be entered, it can be entered very easily into the table by simply putting a new distinct entry of S50 in the primary key column SID and then filling up the remaining entries for SName, SCity, SState for that student Pranav having SID as S50, as can be seen in the table. The device information has been kept null for the student called Pranav, as this student did not purchase any device. Now let's take another scenario. What would happen if a new device information such as D40 for DID, rubber for DName, 200 for DCost, 10 for DProfit and 2 for QTY has been entered, that is not purchased by any student? Then in that case it cannot be inserted because the primary key column SID cannot be null. So this is the case of an insert anomaly. As a result, every device information has to be associated with a particular student. So information about new devices cannot be entered unless it is purchased by a student. The second type of anomaly is the update anomaly. Update anomaly arises due to non-synchronization of data while updating certain columns in a table. That means some entries in a column might get updated whereas some entries may not. In the next slide, I will explain it with the help of an example. We have seen that update anomaly arises due to non-synchronization of data while updating certain columns in a table. That means due to non-synchronization of data, certain columns get updated and certain columns not. Now consider this table. Say you want to update the device named RAM having DID as D10 to paper using the following update statement. That is, update student device, set DName equal to paper where DID equal to D10 followed by a semicolon. Now the question is, what will happen if it is correctly updated in two places but not updated in one place, which is shown by the following table. In this case, D10 refers to RAM as well as paper, which is clearly ambiguous, as two devices cannot be assigned for the same device ID, which in this case is DID having the value D10. This is known as non-synchronization in a table, which is the case of an update anomaly. The last type of anomaly is the delete anomaly. So what is a delete anomaly? A failure to remove information of an existing record from a table causes delete anomaly. In the next slide, I will explain it with the help of an example. Consider the table in this slide. Let's say the student Tushar is going to a place called New Jersey in America, and so he wants to delete his name from the table student device. In this case, pen drive is purchased only by Tushar, as can be seen in this table, and if his record is deleted, then all information related to the device pen drive will be lost. So this is the case of a delete anomaly. So let's take a summary of what has been discussed. A table is in first normal form if it does not contain multi-valued attributes. A table in first normal form is not free from anomalies such as insert anomaly, update anomaly, and delete anomaly. Let's start with the second normal form. So when is a table said to be in second normal form? A relation or a table is said to be in second normal form if it is already in first normal form. Then every non-key attribute is fully functionally dependent on the primary key. If it fulfills both these conditions, then the table is said to be in second normal form. I will show with an example in the next slide. We all know that a primary key uniquely identifies all the records in a table. So the primary key column is known as the key attribute, and the rest of the columns are said to be the non-key attributes. The non-key attributes are said to be functionally dependent on the key attribute, which is the primary key. But there can be a situation where two columns combined together forms a primary key. Such primary keys are known as the composite primary keys. In that case, the rest of the columns in the table, which are the non-key attributes, should be functionally dependent on the entire composite primary key through full functional dependency, and not on the partial attributes of the composite primary key through partial dependency. In this table, the attributes SID and DID combined together forms a composite primary key. Since the non-key attribute QTY functionally depends only on part of the composite primary key, which is DID in this case, as shown by the arrow, it has partial dependency, and the table is not in second normal form. Now look at this table. In this table also, the SID and DID combined together forms the composite primary key. But the non-key attribute QTY functionally depends on the entire composite primary key, as shown by two arrows, which is both SID and DID taken together. So it has full functional dependency, and the table is in second normal form. This was the table student device, which we have just discussed in the anomalies section. It was in first normal form, but suffered from insert, update and delete anomalies. In the next slide, I will show you how to overcome these anomalies using the second normal form. Now look at the diagrams in this slide. Just to remove the anomalies in the table student device, I have split the table student device into three different tables. Those are the table student, the table device and the table purchase. Now look at the splitted tables. In the table student, SID is a column which holds distinct values as there are no repeated entries. That's why the column SID, which holds the values S10, S20, S30 and S40, is a key attribute and is the primary key column of the table student. The rest of the columns SName, SCT and SDate are the non-key attributes. This is because they are functionally dependent on the SID, which is the primary key. Similarly, in the table device, DID is the column which holds distinct values as there are no repeated entries. That's why the column DID, which holds the values D10 and D20, is a key attribute and is the primary key column of the table device. The rest of the columns dname, dcost and dprofit are the non-key attributes. This is because they are functionally dependent on the DID, which is the primary key. Now look at the table purchase. This table holds the information about the number of devices purchased by each student, which in this case is the quantity. The quantity of device purchased by a particular student is represented by the column QTY in the table purchase. Now, we also need to find out the student and the particular device associated with the quantity. This is represented by SID and the DID columns, which together forms a key attribute and uniquely identifies every row in the table purchase. As SID and DID together forms a key attribute, so it is known as the composite primary key. As a result, the non-key attribute QTY is functionally dependent on the composite primary key, which is the key attribute SID and DID taken together. QTY is not functionally dependent on the partial attributes, such as SID or DID taken alone. So it has full functional dependency and these tables are in second normal form. In this way, on splitting the table into three parts, we can easily add a new student record in the student table, a device record in the device table, and the information about quantity of device purchased by a student in the purchase table without encountering insert, update or delete anomalies. As a result, the anomalies have been eliminated and the tables student, device and purchase are in the second normal form. Now check the table purchase in this slide. A new entry with SID as S10, DID as D20 and QTY as 3 has been inserted. That means the student with SID as S10 who initially purchased the device with DID as D10 has purchased another device with DID as D20 and the quantity purchased is 3. This shows there are duplicate entries of S10 in the SID column and D10 in the DID column of the table purchase. Hence, the columns SID or DID cannot become a primary key in the table purchase individually. That is why the attribute QTY in the table purchase is not functionally dependent on the columns SID or DID alone. But if the columns SID and DID are combined together, they form a composite primary key which uniquely identifies every record in the table purchase. As a result, the non-key attribute QTY in the table purchase is fully functionally dependent on the composite primary key with the columns SID and DID taken together. This shows that the non-key attribute QTY is not functionally dependent on the partial attributes such as SID or DID taken alone, but it is fully functionally dependent on the composite primary key with the columns SID and DID taken together. Hence, the tables are in second normal form.